Hi, and welcome to the Science Show. The current video is demonstrating the effects of latent heat on an object, in this case, what is supposed to be paraffin wax. Latent heat is the term used to describe the process in where an object changes state, such as a solid going to a liquid, or a liquid going to a solid, as it happens in this practical. Now, what is occurring in this practical is that the wax has been heated up beforehand and then immersed into the water to cool down. What should happen is that over a period of time, the wax cools and solidifies when it reaches a freezing point. However, this was not so in this experiment because a certain type of unknown wax was used instead of paraffin wax. As a result, the freezing point for this substance was much higher than what it is for paraffin wax. And as a result, when it was immersed in the water, it froze immediately at about 55 degrees. This was not what we had expected to observe at this point in time, and we were all quite curious as to why, as this unusual wax mix hadn't been explained to us beforehand. Now, in a few seconds, there will be some water poured into the beaker. As a result of this, you will be able to see the first-hand process of what happens when the liquid wax solidifies in this point in time. As you can see, as the water is poured in, the wax quickly solidifies, also changing state and changing color. The wax becomes like this because it is trying to equalize its temperature with the temperature of the water and the temperature of the atmosphere around it. Now, in front of you at the moment is the table of results. As you can see, from 26.5 seconds into the experiment to 33.5 seconds into the experiment, the temperature stayed at a constant 58.5 degrees through these periods of time. There was a second block from 73 to 76.5 seconds where the temperature stayed at a constant 53.6 degrees. These two spikes are indicative of latent heat, as the latent heat is when the energy, instead of being used to heat or cool, is dispersed as it changes state. As a result, there is no change in temperature, as the energy, instead of being used to heat or cool, is being used to change the state of the object. This is why these temperatures stay the same. So this shows that we have had a change of state in this practical. So this data confirms our hypotheses that we would in fact see a change of state, as reflected by the descriptors to the practical that we were given. The current data on screen at the moment is the graph taken by the digital thermometer. As you can see, the two main bubbles, that are the first being in the middle where the downwards red line is. The second is at the top of the second peak before it goes into the big long slope downwards. This data was captured with a digital thermometer and is quite accurate. However, the spikes in temperature are due to us touching the temperature probe while the experiment was going on. As a result, the data is fairly conclusive. However, it makes it hard to see where these spikes are, and the quality of the beads did not help us. Thank you for watching, and goodbye.